Well, hello everybody. Hey, here's what I need to do with you today. I need to continue on from our day 2 optimization where you have those geometric figures and we had to minimize or maximize volume, surface area. What I'm going to do today is I'm going to do two things with you. I'm going to take those optimization problems that we had the other day and I'm going to add in the cost to them. So I'm going to change our primary equation, usually from surface area, to a cost equation. Then I'll show you how we'll do that, of course. And then I'm going to turn around and I need to review, I'm hoping it's review, those business applications that we've been dabbling with all year. Kind of clean those up and make sure that you understand how to minimize the cost while maximizing the revenue. Then, of course, the worksheet will be, the assignment will be a worksheet that I won't collect next time. I'll collect the time after, but of course you'll have another one next time. So if you would, come over to your number 1 on that little half sheet that you should have. Should have that little half sheet. So here goes. It says a box with a square base is going to be made which will hold 12 cubic feet. Well guys, I'm going to start here. I'm going to sketch myself a three-dimensional box. Yours is probably prettier than mine. And I'm going to label it so that it has a square base and some height. Remember, you can't call that height x. Now, I know it's going to hold 12 cubic feet. So my constraint equation is going to be the volume of this box is equal to 12 cubic feet. Now, I'm going to attack the primary equation in 2 steps. My primary equation is going to be a spin-off of the surface area. So let's go get the surface area of this box. And then, since it does say the top and the bottom, I know it's not a closed box. So the area of the base is x squared, and there's 2 of them. So I've got 2x squared plus the area of the sides will be xh times 4, so I got 4xh. Now, let's read on the problem now. Material for the top and the bottom will cost $3.50 a square foot, and material for the sides will cost 2. So now I'm going to turn this surface area equation into a cost equation. So the surface area of the top and the bottom is 2x squared, and that material costs $3.50 per square foot. So I took my surface area, the area of the top and the bottom, times 350, plus the area of the sides is 4 times x times h, and that costs $2 per square foot. Now I'm going to simplify this cost equation so that I get 7x squared plus 8xh. Now I'm going to get rid of my box so I got plenty of room to write. Now, the steps are just like what we did the other day. Come up and solve your constraint equation for some variable. Of course, I'm going to pick h. Into our cost equation, I'm going to sub h in, so I got 7x squared plus 8 times x times 12 over x squared, just like we did last class. Let's simplify. So I've got 7x squared plus 96 over x. Now we'd like to minimize it or maximize it, so let's find the derivative and set it equal to 0. So I've got 14x minus 96 over x squared. I'm going to move the 96 over x squared to the other side. That way I can cross multiply and get 14x cubed equal 96. Let's divide both sides by 14 and get about 6.857. And then let's cube root both sides and get x to be about 1.9. So now I know the length and the width. I need the height, so just like last time, let's take this 1.9, plug it in for h. If you run that through your calculator correctly, you're going to get H to be about 3.3. So now, the dimensions of my box. Remember, we listed length by width by height. So my length is going to be about 1.9 feet by 1.9 feet by 3.3 feet to minimize the cost while still yielding to my volume. Okay, so guys, the same steps as we did, but we got to tie in costs today. Now, come over and peek at your number 2. I figured I'd do a box today, a cylinder, and then we would just set up one other, and then we'd roll. So here goes my number 2. A cylinder is to be made that'll hold 8 cubic feet. So right there, guys, I already know my constraint equation. I'm talking about the volume of a cylinder, pi r squared h, and I'm going to set that equal to 8. So there's my constraint equation. Now, be careful on the next parts. Material to make the top will cost $2.50. Material for the bottom will cost $3.50. And the material for the sides will cost $2 per square foot. So when we go get our surface area, I'm going to leave the top and the bottom split up because they have different prices. So since it's a cylinder, I've got the area of the base, pi r squared, plus the area of the top, another circle, so another pi r squared, plus the side, which is 2 pi r times h. Now, let's turn this to a cost equation. So here's my bottom. My area of the bottom is found by pi r squared, and it's going to cost me $3.50 a square foot. So my cost equation is going to be 3.50 pi r squared plus the top is $2.50, so I got $2.50 pi r squared plus the side, which is 2 pi r h times 2. So I just slipped in the cost per square foot on everything. Let's simplify that. 350 and 250. So I've got 6 pi r squared plus 4 pi r h. So there's my main constraint equation. Now, let's come back up into your constraint equation and solve for h. So h is going to be 8 over pi r squared. Let's sub that into your cost equation. So I've got 6 pi r squared plus 4 pi r times 8 over pi r squared. Let's simplify that, and I'm going to get 6 pi r squared plus 32 over r. Now we haven't done any calculus yet, so let's find that derivative, set it equal to 0. So I'm going to get 12 pi r minus 32 over r squared. I'm going to bring that 32 over r squared to the other side. So I can do this. Let's cross multiply. So I've got 12 pi r cubed equal 32. Now, to solve this thing for r, be careful. R cubed is going to be 32 divided by 12 pi. When you run that part through your calculator, make sure you put that part in parentheses. If you don't, your calculator is going to move the pi back up. And then after you get done with that, let's take it to the 1/3 power. And if you do that correctly, you might grab your calculator and make sure you're going to get r to be about 0.95 of a foot. Now, of course, now I need the height, so let's take that 0.95 and run it right back into there. And if you do that, you're going to get your height to be about 2.82. Which, guys, if you think about this, those dimensions make sense. The top and bottom are expensive compared to the side. So I would have a smaller top and bottom, but a taller container, because that's where my lesser cost would be. So that makes sense to me. Now, if you ever need to find the cost, I would just take those numbers and plug in. Now, I just want to set up number 3 because I don't want this video to be 45, 50 minutes. So here's our number 3. Bill is planning on enclosing a rectangular area of 250 square feet in his backyard for a play area. He's going to use chain link fence on 3 of the sides, which will cost $7 per foot. And then he's going to use vinyl fencing on 1 of the sides, which will cost $16 a square foot or per foot. What dimensions will minimize the cost? So guys, I'm going to come over with my rectangle. I know I have 2 lengths and I know I have 2 widths. Now, it does not matter how you label this. I know that 3 of the sides are going to cost 7, 1 of the sides is going to cost 16. I imagine the 16 is going to be a smaller side, so I'm going to put a 16 there, and a 7, and a 7, and a 7. Now, let's go set up all of our equations. My constraint equation is the 250 square feet that I have. Well, the area of that rectangle is still length times width is 250. Notice that there's no cost in the constraint equation. Now, my primary equation, which is going to deal with the cost. Well, the cost of this will be the $7 times the length there, plus the $7 times the width there, plus the $7 times the length there, plus 16 times the length there. So if I simplify this, I've got 14L plus 23W, and then the steps will be the same. I would solve this equation for either L or W, and I got 250 over W. I would sub that in, simplify, find the derivative, and then go get the answer. So guys, there's the first part of the day, tying in cost. Now, the second part of the day is we're going to review all of those cost and revenue and profit things that we've been talking about for seems like the majority of the year. Remember, cost is how much it costs to produce an item. Revenue is how much money you bring in. Don't forget this one because it's important. Profit is revenue minus the cost. If a little p equation shows up, that represents our price. You're also going to see again today average cost, average price, average revenue. Remember, to get the average, we divide it by X, divide it by the number of units. And then you'll see this again. Sometimes we find revenue by taking the price that we're charging times the quantity that we're selling. So remember, we can find revenue that way also. So let me click through these examples with you. Here goes your number 1 on that full sheet. A company has determined that its total revenue in dollars of producing X units of a product can be modeled by that equation, where X is the number of units produced and sold. What production level will yield a maximum volume? So guys, when we go get this, I need a revenue equation, which I have. I need to find that derivative, and then I need to set that derivative equal to 0. So let's go get this derivative, which would be 3x squared plus 900x plus 52,500. And we need to set that equal to 0. Now, like I've said before, I like to factor, but I am not going to try to factor that. I'm going to use the quadratic formula on my calculator. If you don't have that, we are stuck with going old school and going quadratic formula by hand. But if you do that, guys, x is either going to be negative 50 or x will be 350. Well, if you think about it, you can't make negative amount of units. So my answer, I need to produce 350 units to produce, in this case, my revenue. So found the derivative, set it equal to 0. Now, before I talk about number 2 a little bit, I put this chart on here to make sure that you understood what's meant by average cost. The math portion of it's going to be easy, guys. We're going to find the derivative, set it equal to 0. But here's what I did. If you sell no units, you're still out $800 for your rent, your utilities, whatever that you've already invested in this business. If you sell 100 units, I went ahead and plugged 100 into this, and it came out to be $824 as your cost. And then I went 824 divided by 100 to get the average cost to be $8.24. Now notice, guys, as you produce more units, notice that the average cost seems to be going down until a point. Traditionally, what happens then is you need more machinery, you need more staff, so there comes some more cost into it. But now, math-wise, here's what we got going. I've got my cost equation right there. We would like to minimize the cost. So my steps, I want to minimize the average cost. So be careful. I need to turn that cost equation into an average cost equation. So what I'm going to do is I'm going to divide every item by x. So I'm going to have 800 over x plus 0.04, my x is divided out, plus 0.002x. So I took our cost equation and I divided it by x. Now, let's find this derivative and set it equal to 0. So I got 0 equal negative 800 over x squared. That goes away, plus 0.002. I'm going to move the 800 to the other side, the 800 over x squared, making it positive, equal 0.002. Let's cross multiply. So I've got 0.002 x squared equal 800. Divide both sides by 0.002 and get x squared equal 400,000. Square root that. So I got x to be about 632.45 units. Well, you can't produce 0.45 of a unit, so let's round that down in this case. So we're going to produce approximately 632 units. In this case, why would we do that? To minimize our average cost. And guys, if you look back at the chart that I made a second ago, it looks like around 600 my price started going back up. So I knew my answer is going to be somewhere between 600 and 700. So that makes a ton of sense to me. Now, my example 3 is just like my example 2. I just wanted to remind you again, here comes average cost. Oops, jumping on me. So that way we could see the math portion of it again. So let's turn this thing into an average cost equation by dividing the cost equation by x. And if I do that, looks like I'm going to have 0.001 x squared minus 5 plus 250 over x. Let's go get our derivative. So the derivative of this looks like 0.002x. The 5 goes away, minus 250 over x squared. I'm going to move the 250 over x squared to the other side since it's negative, making it positive. Now if we cross multiply, I'm left with 0.002x cubed equal 250. Divide both sides by 0.002 and get 125,000. Cube root it, and this one came out nice. X wound up being 50. So we need to produce 50 units to minimize our average cost. Okay. So I did back-to-back average cost ones there with you guys. Now, let me pop over to number 4. There's what I've done for the price, but let me just get to the math of it so that the video doesn't take that long. So here goes my number 4. Find the price per unit, P, that produces the maximum profit given by. I must have thought that was important because it was really big. And then there's my cost equation, and I gave you a little P equation. Now guys, I'm going to underline this word profit. We're trying to maximize the profit. So I need a profit equation. And remember, profit is your revenue minus your cost. Well, but when I look through this, I don't have a revenue equation yet. But my revenue equation is the price that we're charging times the number of units that we're selling. So my revenue equation is going to be that 90 minus X times X, the price that I'm charging times the number that I'm selling. So guys, now I have a revenue equation. It's 90X minus X squared. Now that I have that, we're on a roll. My profit equation is going to be my revenue equation, 90 minus X squared, minus my cost. So minus 100 minus 30X. I'm going to simplify this profit equation, and it looks like I've got negative X squared plus 60X minus 100. Let's find this derivative and set that equal to 0. Now be careful here so we finish this thing out correctly. X is going to be 30. What does that mean to you? It means that we are going to sell 30 units at, now to get your price that we're going to be charging, take this 30 and plug it right there. 90 minus 30 is 60. We are going to sell 30 units at $60 each. That will maximize my profit. So the only thing I added in different, after you find your X value, that's your units, go plug it in to get your corresponding price value. Okay. Here comes another one just like it. I may not do all the math on it, guys, but just to show you the setup and maybe do it a little quicker. My revenue equation is going to be this price equation times X. So my revenue equation is 70X minus 0.001 X squared. Well, now we're sitting pretty good. We want to maximize our profit. So my profit equation will be this revenue equation minus that cost. Now notice I'm going to distribute my negative sign through there. I'm going to go ahead and simplify this. And if I do that, I'll combine that, and looks like I'm going to get negative 0.031 X squared. I'll combine that and get 20X minus 8,000. No calculus yet, so here goes. Let's find this derivative. Negative 0.062X plus 20. Let's set that equal to 0. Let's subtract 20. Divide by negative 0.062 and get about 323 units. So we're going to sell about 323 units at, to get that price, take this 323 right back up to there. So I'm going to sell 323 units, and I've decided that the price we can charge to maximize my profit, $69.68. So be careful, profit, average cost, just kind of read the problem. Okay. Looks like video-wise I'm going to be sitting really good. I've got two more examples. It'll look familiar to you once you see them again. So here goes. It says a business sells 2,000 units per month when they charge a price of $10 each. They can sell 250 more units per month for each quarter in reduction that they give the consumers. What price per unit will maximize the monthly revenue, and assume the demand is linear. Now, let's come over. I want to maximize revenue. I want to maximize my revenue. So I need a price equation. That's not a capital P for primary. That's a little p for price. And I need a quantity equation. Well, let's go write down what we're starting with. Right now, I am charging $10 and I'm selling 2,000 units. That's what I'm doing right here, right now. I'm looking at lowering the price a quarter. So every time I lower the price by a quarter, I sell 250 more units. So in this case, guys, my X represents the number of times I'm going to lower the price, which means that's the number of times I'm going to increase my sales. Now, that means my revenue is going to be my price, 10 minus 0.25x, times the quantity. And the quantity is 2,000 plus 250x. Let's simplify this by FOILing it out. And guys, if I FOIL this out, looks like I'm going to get 20,000 plus 2,500 x minus 500x minus 62.5x squared. Once I simplify this, I get negative 62.5x squared plus 2,000x plus 20,000. Now, finally, some calculus time. Let's find this derivative, set it equal to 0. So I've got negative 125x plus 2,000. Let's subtract away 2,000, divide by negative 125, and get 16. Now, know what that 16 means. It does not mean the price is $16. It does not mean the quantity is 16. It means I'm going to lower the price 16 times. So we're going to take this 16 and plug it right there and right there to get the price and the quantity. So my price is going to be 10 minus 0.25 times 16. So my price is going to be $6. My quantity is going to be 2,000 plus 250 times 16. So my quantity in this case would be 6,000 units. Okay. So guys, the key thing there, get your price, get your quantity. Now, I'm going to just set up number 7. I won't take time on the video to finish it out because I think you know how to FOIL and find the derivative. So here goes this one. We'll just get it set up. The WMA bus lines offers sightseeing tours of Washington, D.C. One of the tours, priced at $25 per person, had an average demand of about 1,000 customers per week. When the price was lowered to $20, so a price reduction of 5, the weekly demand jumped to about 1,200 customers. Assuming that the demand is linear, find the tour price. So guys, here goes again. I need a price equation. and I need a quantity equation. Right now, my price is 25 and I get 1,000 people. That's my right now. When we lowered our price to 20 bucks, so we dropped the price $5. So drop the price $5. What happened? We gained 200 customers. Every price in $5 drop, we're going to gain 200. So guys, that's our price and quantity equation. Our revenue would be, we would multiply those out using FOIL. We would simplify. We would find our derivative, set it equal to 0, and plug that number back in. So guys, there's what you missed. Good luck on it. Buzz in if you have any questions.